All right. So chapter, okay, here we go. Got everything set up. Then I'll save some time after class, see if you have questions, and we'll go from there. So we've kind of already been alluding to infinite limits. I think the first few sections, when they were infinite, you would just say, oh, it does not exist. But technically, an infinite limit is different from does not exist. So now if you notice that the limit is approaching infinity, then you would just say so. So let's check out this one-sided limit. Do you remember what the minus sign meant?
It's coming from the left.
Left side, right? So
Yes.
here is the function. So on the left side, it shoots up, and then it jumps and then it has an asymptote. So in the middle has like a parabolic shape. It's shooting up as well. Then another asymptote, and then it kind of levels off. So from the left, +2 is right here, right? So as we approach, let me zoom in just in case. As we zoom in and approach 2 right there, the y values are shooting off to infinity, right? So it's obviously not defined at 2. So as we approach 2, it becomes infinite. It grows really fast. So 2 is not allowed, but if you plug in 1.99 in here, you're going to get something huge. Okay. So that's basically a hint that it's probably infinite. So it always helps to graph and punch in numbers. You can do all those techniques, doesn't matter. But that is why it's infinite. Does everyone see why this is positive?
Yes.
And let's look at from the right side.
That's why I had
Same
my mic off. I said yes.
shoots upward, right? Right there.
Yes.
So both directions, as we approach 2, goes up really quickly. So both are infinite.
Mm-hmm.
So technically, both directions are going to the same place, right?
Right.
So you could say that the limit as x approaches just 2 is infinite. Is there any questions on the first one? It's not much problem solving here. It's just, do you
Right.
understand the concepts?
Yes.
Okay, I kind of want to get some clarity on this. So if it shoots upward, that means towards the limit, that means it's going to be a positive infinity. And if it's shooting downward, it's negative.
Yeah, that's right. Mhm.
Okay, thank you.
There's a few weird scenarios where the sign is affected by the function, but for the most part, if you look at the graph and you see it diving, yeah, you're right. Like this guy here. There's a -2 right here, right? -1, -2. So there's an asymptote there, so the function's not defined there, but we can use limits to approach it and see what's going on. So as we approach from the left side, the negative side, what's happening?
Going to negative
Negative
infinity.
infinite.
Yeah, it's shooting down.
So that's why we choose this, right? Nothing crazy. From the right side?
Shooting up. That means it has to be positive, right?
Yeah, shooting upward, so infinite from the right, negative infinity from the left. They're not the same, but the individuals do exist. Okay. But there are different types of infinity. And if you became a math major, there's different levels of infinity too. But it's not, don't worry about it. Number 3, -6. Oh, here we go. It's right there. You can pretty much see with the graph, right?
Yes.
Never crosses the asymptote, so it gets infinitely close. So the closer it gets, the steeper it becomes. That's why it's growing so fast. Okay. Are there any questions on this idea? They're pretty straightforward.
Pretty straightforward.
Okay. Let's move on to something else. Let's see what's going on here. Over here, they have us use the first approach we learned. It's kind of what I was talking about earlier. 2 is not allowed, or -2 rather, or either one. But they're talking about -2. So as we get closer and closer to -2, see how fast it grows? Just by adding another decimal place. So it's clearly approaching infinity from the left, right?
Mm-hmm.
From the right, looks like
Negative infinity.
-infinity. So which graphs fits this idea?
Not those two. It's the third one, the one on the bottom left.
From the left, we said positive. From the right, we said negative.
Yes.
Can't be D. Yeah.
Yeah.
The only one that was kind of close is the first one, but it's reversed, right? The other two make no sense. Can't be this. Any questions on what you would do here? Do you remember the?
Yeah, I remember how to fill in the tables.
Yeah.
Mm-hmm.
Hey sir, would you mind showing us at least one example? Because I was just having difficulty trying to do this part.
Yeah, sure. So, what calculator do you have?
Uh, Not too sure. It's my girlfriend's. It's like a Texas Instrument something.
Is it the graphing type, or is it the
Just
84, 83?
yeah, I believe it's the 83. But I'm
Oh,
mostly just using Desmos.
no, we could do that if you want. Here, let's pull up Desmos. Can y'all see the graphing?
Yes.
Yes.
Yes, I actually used Desmos during the homework.
Yeah, it's really user friendly.
Mhm. I just hope that it's allowed on the I just hope it's allowed on the exam because I do not have a graphing calculator on hand yet.
I got my graphing calculator on Facebook Marketplace for a steal.
Nice.
I don't know if the lockdown browser will let you use another open window,
I'm gonna
unfortunately.
try to allow that to be the only window to pop open, but I can't guarantee it. Well, I'll see what I can do. Okay, -4. Oops. Okay. What was there next on top? Oh. Okay, so we were curious about -2, right?
Yes.
So just keep approaching really close to it. So -2.01. There's the output, the Y value. Let's add another 0. As you can see, we keep adding more zeros. It gets pretty huge the closer I become to -2. So all they want you to do is plug in the number into the X, calculate it, and write down the number. So the first one would be -2.5, so you plug that in into here. And you can do that with any calculator.
Right.
And as you get closer, you should see it increase. If you see it become really negative quickly, then it's negative infinity. If you see it get really large, positive, then it should be positive infinity. But graphing, I think, is the best way to go, right? Because you can see it shoot up right there from the left side and then shoot downward from the right side.
Okay. Yeah, I get it. I get it now.
It's the same type of stuff. Do you remember how to find vertical asymptotes? This is a review of college algebra right here.
Yes.
You explain
Uh
it. I believe I forget it.
yeah, I wouldn't mind going
So,
over it. I graduated in 2013, so
so what's happening here is that if you factor the denominator, you're going to get something that cancels out with the numerator. So it's there is a removable discontinuity that exists in this function. Therefore, the limit, the vertical asymptote does not exist.
Let's see. Vertical asymptote. Let me switch over. Let's write down the ideas, right? The approach. So to find, let me write the note down, just to remind y'all, a vertical asymptote set the denominator equal to 0. I'm going to use X because my T's look like plus signs. So technically what you're supposed to do is this, but can that be 0 ever?
No.
No.
Right? No matter what I square, it's always going to be positive, right? So there's no way it would cancel the 9. It's impossible. Do you agree? A square plus a 9 can never be 0.
Yes.
That's correct.
So because there's no solution, there's no real solution. There's complex solutions, but not real. So that's why there's no vertical asymptotes, because this has no solution. So since the denominator is never 0, then there is no vertical asymptote. Because vertical asymptotes only happen when you divide by 0. So if you have a point or value that will cause 0 at the bottom, that's the vertical asymptote. So that first example up top, what was it again? You had the x squared minus 4 on the bottom, you remember? That did have a solution, but this doesn't. There is no sum of squares factorization.
Thank you.
Now, if it was a solution, let's say it was x squared minus 9, which I feel like that's the first thing you think of when you see this, but it turns out it's not, right? Then you would factor and you'd have 2 vertical asymptotes. So let me show you, just to remind you. And if you want some random notes from college algebra, I can send them to you, just let me know. So here there is no asymptote, at least no vertical type. But if I change this to a minus, then we have things that will cause 0 in the denominator. So you have the asymptote at -3. We don't have it at +3 because it'll cancel. So that would be a removable type, which would happen over here. So it's still undefined, but there's no asymptote. Okay, so if it was, let's say, a 1 up here, then you would have 2 asymptotes because there's 2 values that cause 0 at the denominator. Okay, does that make sense?
Yes.
Yes.
Do y'all
Yes.
remember asymptotes? They're basically a boundary that you can't cross because If you do, you would divide by 0, right? Let me find let me see. What the hell is it? 13, 14 files. We should have some in there. Yeah, here we go. I don't think I'm going to get super deep into asymptotes, but I'm going to give you the notes anyway. Alrighty. Now, another place that has an asymptote is anytime the logarithm has a 0, because it's not defined at 0. So if you're to graph any logarithm, right, we can't use 0, but it approaches it. It's outside the domain. And we had -3, right? So all this does is shift it over. So it's the same issue. So we cannot have any value that makes it negative or 0. So the domain of all logarithms is x is greater than or equal to 0. So as long as your result in here stays above 0, then you're good. So 3.1, -3.2 is fine. -3.1 is cool, but not -3. Okay, can't use that. Excuse me. Does that make sense or no?
Yeah.
Yeah, asymptotes. So this one's pretty clear, right? Can't have 2 down there, so vertical. This one is a removable type. So if you factor the top, you're going to cancel this factor. Okay, because this is the one that becomes, let me see. Let me share number 11. Yeah, let's just work it out real quick. 11. Got the question. Determine if it has a vertical asymptote or a removable discontinuity. So it is removable if you can factor and cancel the division by 0 part, or at least at x equals -2. So we know the top is a difference of squares, right?
Right.
So this is gone. So because you can do this, then you say yes, it is removable. It's because of this reason. So number 11, there is no vertical asymptote, but it's still not defined at -2.
Okay. So the reason why number 8 was not a vertical asymptote, the same reason.
Number 8 was did not have one because no, not the same reason, not at all. It was because there was no solution to the denominator. You can't factor this. So since it doesn't factor, you can't
Oh,
solve it.
okay. Just
You will never have division by 0. So if division by 0 never happens, then there's no reason to even be talking about vertical asymptotes. So,
Okay, I'm gonna write that down real quick.
so vertical asymptotes are caused by values that might cause zero in the denominator. That cause zero in the denominator. So there was nothing that would make this zero. Therefore,
Okay.
none.
Okay.
Let's see. So that's pretty much 2.5. Y'all have any questions on one-side limits that go to infinity, removable discontinuities, or the graphs and the ideas?
Can we go over number 13 real quick?
Let me go back. Sure. Excuse me. So they want us to graph it. So here they're actually making us do it. Go. So as we approach 2 from the left side, what's going on? X squared minus 4. Wait, positive 2, sorry.
Positive 2 from the left.
Shoots downward here, right?
Right.
So negative infinity would be your one-sided limit.
Let's say, okay. Can I see the problem again? Wait, if we're approaching 2 from positive 2 from the left side. Oh, okay. But wait, no, that's the right.
There's 2, so as we get closer and closer,
Positive 2 from this. Okay, okay, I get it. I get it now. I get it.
yeah, it threw me off too because I kept thinking of a negative 2. I'm like, no, it's 2 minus, not minus 2. But yeah, that's all it is.
Okay. Yeah, that one confused me real bad because it made me realize that I really need a graphing calculator for this exam, just in case you're not able to get Desmos on there.
I don't think the exam would really require it. Trying to remember the questions. I want to say either I'll give you a picture or there'll be simple functions, but the homework is a different story. Those are the homework questions are usually harder than test questions on purpose,
Hmm.
right? That's how it's supposed to be. I'm not saying everyone does that, but they should.
I recommend Facebook Marketplace for calculators.
Okay.
That and pawn shops, there's a bunch of them there.
Juan's asking if the exam is multiple choice.
And there's multiple choice answers, but the answers don't matter.
What matters is the work that you show.
Right. I'm grading the work, not the answer you choose. If you choose the right answer and give me garbage, then you're not getting any points. Let's see, 5, 6. I don't think we can do this yet. I just realized it would have to be done after chapter 3. My bad. I'll move this to a different time. Because we need derivatives. We haven't discussed them.
Yeah.
So that date will change for 5.6.
Okay.
Okay, so I'll let you review on your own, and then maybe, I don't know, let me figure out next week. For sure, we're gonna do these two. And we'll go from there. But you have any random homework questions? Y'all struggling with anything?
Emily's
Yeah.
asking Emily's asking if the questions are coming primarily from either the review or the homework.
It'd be very similar to the review. That's the whole point, right? You practice review, that way you should be ready. The homework is get a good understanding, and then the review should prepare you for the test.
Okay.
I'm not going to try to trick you or surprise you. Just it's not the point. All right. Let me take roll and see if you have any questions. Overall, you guys doing okay on the homework?
Yeah, we're all doing okay.
Yep.
Yeah, having to relearn a lot of the stuff because it's been a while since I've taken any math courses. So I'm kind of having a bit of difficulty, but there's a lot of YouTube links and plus the links you provided. Just have to watch them multiple times in order to get it.
That's true. I think if your algebra skills are great, then this class is very easy. If they're rusty, then this class becomes really hard, and that's just how it is.
Yeah, it's been a minute.
But yeah, you don't use it, you lose it. That's how it goes. All right, let me take roll. Romina, you here?
Here.
Cade Brown,
Here.
Megan Dean,
Here.
Lolita Felton,
Here.
Dennis Garcia,
Here.
Sierra Jaramillo,
Here.
Nigel Macias,
Macias here.
Macias, sorry, Eleni,
Here.
Matthew Martinez,
Here.
Sarab,
Here.
Brittany,
Here.
Gabriella,
Here. I'm here.
Garrett,
Here.
Haruka.
Here.
All right, guys. If you feel like you're good and you don't have any questions, you're welcome to head out. But if you're struggling with something or concerned about something, please stick around and let me know. Okay.
So we don't have a class next Thursday. I mean this Thursday.
Yeah, not this Thursday. I have a doctor's appointment and some other stuff to do. But we'll see you next week. For now, review with the video.
Have a good night.
Have a good night.
Good
Have a
night.
good night.
Thank you. Good night.
Thank you.
A good evening, sir.
You too. Have a good night.
Mr. Gonzalez,
Mhm.
I won't be able to attend class Tuesday as I told you it's my birthday. Is that okay?
Yeah, that's fine. Just I would recommend do the review this weekend and watch the 3.1 videos. That way you won't get behind because
To be honest with you, I really don't have any problems with math. I love math and
that's good. That's
any
good
problems with math, to be honest with you. So I'm actually here teaching everyone math.
It's awesome.
But
It's how
yeah,
it's how you master it. It's just you start teaching people or helping people, you really grasp it.
yeah, I always help my brothers and all my cousins, whoever have problems with math. They're like, okay, let's call Romina. So I'm the one who always teach them.
Funny. What's your major?
I'm biology. I'm trying to be a dentist. So
Oh, okay.
Iran, I used to be a dentist there, but I couldn't continue here and they did not accept my paperwork. So I'm trying to do everything all over again.
Oh shoot. So you already had all your
Yeah, I
stuff.
already have everything done, and I was a dentist there for about 2 years, and they did not
Oh.
accept any of my paperwork.
Where at, you said?
From Iran.
Oh, I see. So they didn't let you transfer
That's
over.
the country, to be honest with you.
Mm,
They have
yeah.
problem with, but I mean, it's all good. Yeah, I just have to do everything all over.
Oh, that's frustrating. I'm sorry.
Yeah, no, it's fine.
At
But
least it'll be easy for you, I guess.
it is, yeah. It's going by quick, so we'll see what happens. But anyways, thank you so much.
Yeah, good luck, and I'm sure you're gonna succeed.
Appreciate you. Have a great night.
You too.
Thank you.